Hello everyone, and welcome to part 2 for Python sockets. Now there's not really anything left to talk about the module itself in order to learn how to use sockets. Part 1 pretty much covered all the important stuff. Instead, this video is one of the few that will cover various important things relating to network programming. In this video in particular, I'll be showing you how to program your server or client program, how to determine when it has finished receiving a full message. This tutorial will be using TCP connections only. I'm not an experienced network programmer, so I may butcher the explanation as to why, but I'll give it a shot. The reason this lesson will be focused on TCP connections is because they are where defining the start and end of messages is the most difficult. After all, the protocol is designed to consistently stream data over a connection, and will likely be receiving multiple messages at a time. So it's important to be able to devise a way to separate the messages that they are receiving. UDP, on the other hand, is not really something to worry about here because it's a connectionless protocol. When you send a message over a UDP socket, you are usually sending it all at once and the server is expected to receive it all at once. That's what UDP is designed for, to send and receive data all at once as a single message, one message at a time. You wouldn't, well, you shouldn't, split a message into multiple UDP packets because the integrity of that message will not be guaranteed like in a TCP connection. Which means the start and end of a single message over UDP should be pretty easy to figure out. So with the explanation out of the way, let's jump into the code. The first method we can use for TCP message lengths is a pretty simple one. We implement a fixed length. This method will work even when our actual message payload may vary in size because we can simply use a random character to pad out the remaining space. So we're going to look at the client first for this example. Nothing special about the server report, it's pretty much the same as before, but after that, I establish a constant message length size of 45 bytes. And then I have a list of messages that I'm going to send over the connection. The first message is 45 bytes long, so it's the max size. The second one is 13 bytes long, and then the third one is 25 bytes long. And then down here, after I connect to the server, we go through the list of messages, first checking to see if its length is equal to or less than 45 bytes. And if it's less than 45 bytes, it's going to pad it with the # character here, the number of times it needs to until the length of the message is now 45 bytes. And then after we do that, we send it over. And then on the server side of things, we establish the message length as 45 bytes here as well. We have to. They have to be the same so that there's no inconsistencies when it's receiving messages. And so once we receive a connection from the client, we start listening for data. And if at any point the messages stop coming, then it will close the connection and break out of the loop. But for as long as we are receiving messages, the first thing we'll do is, of course, decode it. Then it will print the data as is. So we'll see the messages with the padding symbols if there are any. And then after that, we'll add the message to a list of received messages while also stripping the padding characters off of the strings. And then once we receive all the messages and the socket is closed, then at the very end of the program, we go through the messages one by one and print them out. So we'll get to see them without the padding characters as well. So I've got the server running for example 1, and then I'm going to run the client for example 1. And so it says it's sending all of this data. It's padding the messages for this one and this one because it's less than 45 bytes long. And then over here, we see the raw data received. And then down here, after we received all the messages, it prints out the strings without the #. So that's one way to handle message lengths. Another way is to use a delimiter to signal the end of a message. The delimiter can be whatever you want it to be, but it's important to use a combination of characters that would not also be used in the message itself. So in this example here, I have 4 messages. And down here, when we connect to the server, we add 3 # to the end of each message before we send it. Now, a # is probably not the delimiter you would want to use in your messages because that is something that you might actually see in the message itself. It's better to use something that you're less likely to actually ever put in a piece of data. One delimiter you might typically use would be /r/n, because that's not something you would typically see in regular data. All right, so now we have our server here, and we set a message length of how many bytes we're going to take in at a time at 30, just simply so the messages can be a little bit smaller, but we could still have enough room to see messages sort of come in one after the other. And this will help show you like how raw data comes in over TCP, especially with the delimiter. So after we get a connection from a client, we start reading in the data, and again, if we don't receive data, we close the connection. Down here, we print the raw data. So we'll see the raw data as is, including the delimiters. And then we check to see if the delimiter exists in the current 30 bytes that we just read in. If it doesn't, we just add the data to the buffer, then come back to the top and read more data in. And we'll keep doing this until we received all the messages and we've hit all of the delimiters, because the client will add a delimiter to the end of each message. So we won't, at least in this case, we don't have to worry about receiving a message that didn't have a delimiter added to it, or maybe the connection died or something. We're not going to worry about those scenarios. But if the 30 bytes did have a delimiter inside of them, then we go through this while loop, separating the data out by the delimiter so that we can complete one message and then move on to the next message. And we do that using a string method here called partition. What partition does is it takes a string value you put in and it searches for the first instance of that value in the string you're partitioning. It then splits the string up at the location where it found the first instance of the string value here, and it will return a tuple of 3 values. The first value is the part of the string that came before the delimiter here. Then the second value is the delimiter itself, and then the third value is the rest of the data. And after we partition that, we take the first value, our buffer data, that's basically the end of the current message, and we add it to the buffer message, and then we append that buffer to our list of received messages. Then we clear the buffer, and then we loop through the current message again to see if there's any more instances of the delimiter here. And if there is, then we continue the process to separate the data out. And then, like before, at the very end, we go through the list of messages that we've received and we print them out. So I've got the server running. I'm going to run the client now. So here's the raw data here. We're receiving 30 bytes at a time. And as you can see, the first message got cut off a bit because it's more than 30 bytes long. But the remaining 15 bytes you can see down here because it got the rest of it. That's the good thing about TCP connections is even if you don't get the entire message in the first read, the next read will get the rest of it. And so when we get our second read here to get the rest of the first message, as well as the delimiter to signify the end of that message, you can also see it also managed to pull in some of the second message. So this is what I wanted to help demonstrate with the way I coded things here between the client and the server, with how I got the different sizes here and making a small message read here so that you can see it get bundled up together. That's also why I chose pound signs as my delimiter rather than something more typical like /r/n. /r/n is typically a delimiter you would use for end of messages like this because that's not something you would see in the message itself. 3 pound signs you could probably see inside of a message, and that might cause confusion if you were trying to use that as your delimiter too. But I chose this simply so you can see it in action very clearly. And so anyways, and then our third read, we get the remaining part of the second message, which was just a single T followed by its delimiter. Then we get the next message, small message, and its delimiter. And then the first part of the final message here. And then the fourth read will get the rest of the final message followed by its delimiter. And so this basically shows why it's important to help your client and servers understand how long the messages they're expecting to receive are over a TCP connection, because it will just keep getting the data at no end. It will just keep reading in stuff, and it just assumes it's all one single message until you actually write the code in to break it up into its actual individual messages. Then down here, this is after we've broken them up, we've separated them by the delimiter and everything, and we've got our 4 individual messages right here. And so that's the second way we can handle message links with our network programming. The last method I'll cover is the act of including the size of the message inside the message. Now, this is the method that I prefer using for any of the programs that I write that utilize networking. I don't do a lot of networking, but when I do, this is what I use. So basically what we do is we measure the length of our messages, convert that number into bytes to be sent over to the server or the client so that the endpoint will know, okay, I'm about to receive a message of this length. So the first thing we do is measure the length of the message. Well, technically the first thing we do is encode the message. You have to measure the length of the message after it's been encoded, because converted into bytes, it's going to be a little bit longer than if it was just as a string. And then after we get the length, we have to convert the length into bytes so that we can send it over the socket. And to do that, we use an integer method called 2bytes. 2bytes takes in, at a minimum, 2 parameters. The first is specifying the number of bytes you want the integer to be converted into. And then the second parameter is specifying the byte order. Now, what byte order you use does not really matter as long as you make sure that both endpoints use the same byte order. And in this case, I'm setting byte order to big as opposed to little, which is the other option. So I set to 4 bytes. 4 bytes covers quite a long range of integers. You can set it to more bytes if you need to, but I'm going to set it to 4. And then we send first the message length to the server, followed by the encoded message. On the server side, the first thing we do is we listen for the 4 bytes that will specify the size of our message. And we store it into a variable called size header. And we of course check to see if size header is 0 to indicate that no data was sent, in which case we close the connection. And when there is data being received, we have to convert those 4 bytes back into the integer. So we do that using int.fromBytes. And then the first variable we pass in is the variable containing our bytes. Now, in my case, I don't think I have to specify the index size, but if you're reading more at a time, but you still have to read the first 4 bytes for the message length, then you would do that here. I think in my case, I don't actually have to because this is literally all there is in size header, but I did that here. And then we specify byte order, which is big for me because that's what I specified when I converted it to bytes. So that's what I have to specify when converting it back to an integer. And then after I get my message length, next thing I do is I create a message variable that contains an empty byte string. And I specify it like this because when we want to concatenate our message, we have to concatenate a byte string to a byte string. That's why I have this little B here. B indicates that this is going to be a byte string. And then after that, I have a variable here called message downloaded. This is going to be an integer to keep track of how much we've downloaded and make sure that we only download the amount of data that is specified by our message length here, because we don't want to accidentally read in the message size for the next message while trying to process the current message. And so basically, while message length minus message downloaded is greater than 0, we'll keep looping through downloading the message. And as long as it's greater than or equal to 10, we'll receive 10 bytes at a time. And if it's less than 10, then we just download what's remaining, and then we add that to the message downloaded, which will then cause us to leave the loop. And then at the end of the loop, we're basically appending the message piece by piece together, and I'm printing out how much we've downloaded at a given time. This part right here, /r, is basically saying return the cursor to the beginning of the line, so that when you print another message, it's going to overwrite the last thing you've printed out. And in order for that to work properly, you have to specify the end parameter as well, and you have to set it to an empty string. Otherwise, the print function will always add a new line to the end of your message and make this kind of useless. So this will just basically make it look like we're updating the same line over and over again, which technically we are. And this part right here is just to help clean up the screen when we print out the actual message, because some of the messages are so short that when you print them out, you'll still see remnants of this message here when it prints onto the screen. So this is just to make sure that everything from this string here gets overridden so you don't see any of that. And then we print out the message and you'll get to see the data. Got the server running, we're gonna run the client. And we're slowly downloading the data. There's the first message, there's the second message, third, and then there's the fourth. So that's the third method for handling message links when using networking in your code. There may be other methods as well, but these were the methods that I'm most familiar with. But that's pretty much how you would handle message links when using network programming. So I hope you've enjoyed this video and found it helpful, and if you did, then please hit the like button and leave a comment below to let me know what you think. And if you want to see more, head on over to Wayfair Coding Academy channel to check out my other content. And while you're there, subscribe to the channel to stay up to date on new stuff as it comes out. Thanks for watching, and I'll see you all next time.